This is section 8.3. This is part 2. We're supposed to combine these two. The first thing we need is to simplify our radicals since they are not exactly the same. So I'm going to have -5 times. I need to simplify the square root of 32, so I need the prime factorization of 32. And I glanced through everything we have done, and I do not see a 32 anywhere. So I'm going to find the prime factorization of 32. Remember, we want to find a prime number that divides evenly into 32. Since it's an even number, I know I can divide it by 2. And then that gives me 16. And then a 2 divides into that as well, giving me 8. And then 8 is divisible by 2, which is 4. And 4 is divisible by 2, which gives me a 2. If I'm looking for the square root of 32, I'm looking for pairs. I have a pair of 2's, I have another pair of 2's. So a 2 comes out, another 2 comes out. 2 times 2 is 4, so a 4 is on the outside. And I have a 2 left over, so it's 4 times the square root of 2. So right here, I write 4 times the square root of 2 plus 2 times. All right, the square root of 98. I glance to see if I have that 98 here anywhere, and I do not. So let's find a prime factorization of 98. 98 is even, so I'm going to divide it by 2, and I get 49. And 49 I recognize as 7 times 7. So the square root of 98 is going to be, I have a pair of 7's here, so 7 is on the outside. I have a 2 left over, so 7 times the square root of 2. Okay, now I do -5 times 4, which would be -20, square root of 2, plus 2 times 7 is 14, square root of 2. Remember, we can only multiply the numbers in front. You can't do anything with this because this is the square root of 2, which is 1.4 something, I believe. And so it's not really a 2. Now, we had to do that much anyway to simplify. Now we look to see if we could combine them. I have square root of 2 on both of these, so I am allowed to combine them. -20 plus 14 would be -6, and then keep the square root of 2. Let's use our calculators to see if this one will check. And I do get -6 square root of 2, so that one is correct. Okay, so let's go to the next problem. This one is bigger. It's not really that much more difficult. We just have 3 things to add instead of 2. We might end up being able to combine them all. We might end up being able to combine 2 of them, but not all 3. We might not be able to combine any of them. We just have to see. Okay, so I need to simplify this. 11 is a prime number, so this one is not going to simplify at all. I'm just going to bring it down. Plus, okay, 5 times. All right, the square root of 44. So let's look at here, and I do not have a 44 anywhere, so let's find a prime factorization of 44. It's even, so it's divisible by 2, which is 22, which is also divisible by 2, giving me an 11. So the square root of 44 would be, I have a pair of 2's, and then I have an 11 left over, so 2 times the square root of 11. Okay, minus 8 times the square root of 99. 99 is also not anywhere on here, so let's do a prime factorization of 99. Well, I started off with 2 here, but I could very easily have started off with 11. 11 is an easy one to see if something's if it's divisible by, especially with a 2-digit number. So I know this is divisible by 11 because it's a 9 and a 9. If I divide by 11, I get a 9, which is 3 times 3. It does not matter which number you start off with. I would have gotten the same combination of numbers no matter what. So the square root of 99 would be 3 times the square root of 11. Okay, so here I have 3 times the square root of an 11. Let's simplify each one. This one is already as good as it's going to get. Plus 5 times 2 is 10 times the square root of 11. Minus 8 times 3 is 24 times the square root of 11. Okay. Now let's see if we can combine them. I have a square root of 11 on each of these, so I will be allowed to. So I do 3 plus 10, which is 13. 13 minus 24 is 11. So what I've just done over here is 3 plus 10 minus 24. That's 13 minus 24, which is negative 11. So I end up with negative 11 times the square root of 11. Let's check this if we can. And it is correct.